So I'm going to go through the warm-up problem that I had for you guys that we didn't get to in class because we had to move on. So we have a water balloon. We have 2 water balloons thrown from the same spot at the top of a building, 6 meters above the ground. So we can call this y initial equal to 6 meters and the y final down here 0 meters for both balloons. And you're asked, so one is thrown straight with a horizontal velocity of 2 meters per second. So in the picture I've drawn here, that's the blue water balloon. And then the other one is thrown straight down at a velocity of 2 meters per second, straight down. Okay, so what we're asked to do is to determine like which one hits the ground first, and the time difference between when they hit the ground. So how much sooner one hits the ground before the other. So just by looking at the problem and reading the problem, we will understand that the red balloon here is going to hit the ground first. Okay, the blue balloon does not have any initial velocity in the y direction, and the red balloon has a velocity towards the ground to begin with. Okay, so we're going to predict that it hits the ground first, but we do need to go through the calculations to determine what that time difference is. Okay, so our equation for the vertical position versus time is going to be the y equals y naught plus v naught yt. And then because we've chosen the positive y direction to be up, we're going to put a negative sign for that so we can account for that g being negative. So negative 1/2 gt squared. Okay, looking at our blue balloon first. Well, our blue balloon, its final y position is going to be 0. Its initial y position was 6. Okay, its initial y velocity is 0, so that term cancels out. So we get 0 equals 6 minus 1/2 times 9.8 t squared. Okay, so rearranging a little bit, we have negative 6 equals negative 1/2 9.8 t squared. Actually, let's just multiply that together. 4.9 t squared. Okay, so we divide 6 by 4.9 and take the square root of that to get, it rounds to 1.11 seconds, but on my calculator, I'm going to store that so when I subtract, I don't lose any decimal places and don't have any rounding errors. So it's really 1.1065, like 7-ish. Okay, so that's when our blue water balloon hits the ground. Okay, so now we want to look at when our pink one hits the ground. Okay, again, we can set up our same equation here. And it looks similar, but it's a bit more complicated because there's an initial y velocity. Okay, so we still have its final position is 0, initial position is 6, but then we have the initial velocity in the y is going to be negative 2.00 meters per second times time, and then we still have minus 1/2 gt squared, so 9.8 t squared. Okay, so I made this negative. I drew it as in the downward direction on my picture. So when I plug in my 2 meters per second, I have to make it negative. Okay, so let's go ahead and kind of rewrite and rearrange this. So we have 0 equals negative 4.9 t squared minus 2t plus 6. Okay, so this looks like a time for our quadratic formula. Okay, so plugging into my quadratic formula, we got, so negative b, which is going to be a positive 2 because our b term was negative here, plus or minus the square root of b squared, which is 4, minus 4 AC, so minus 4 times, negative 4.9 times 6, all over 2 times negative 4.9, which is just negative 9.8. Okay, so I'm going to have to go down more. So we have, let's go 2 plus or minus. If you solve for what's in the square root, you get 121.6 all over negative 9.8. Okay, so we take the square root of that, and we get 2 plus or minus 11.027 divided by negative 9.8. Okay, so we want, we kind of have two choices here for our time. So by looking at this, we see that when we do the addition, we're going to get a negative time, which is not what we want. So let's do the subtraction. So we take 2 minus 11, that 11.027, and divide it by negative 9.8, and we get like 0.992 seconds-ish. Okay, so 0.921. Okay, so as we anticipated, this number is smaller, let's see, than this number up here. Okay, so now we just have to subtract the two. Okay, so we want to subtract 1.11 or 1. Let me switch colors here. So we had 1.10657 minus 0.9211. Okay, let me do that on my calculator quick. 10657 minus that, and we get like 0.19, I think is where I round to. Let's look at sig figs. We were given 3 sig figs, so let's keep another sig fig. So 185 seconds. Okay, so the red one is going to land 0.185 seconds before the blue water balloon.